Welcome to section 5.1, video number 3. And we begin with a graph, and we are asked to determine whether or not the graph shown is a graph of a polynomial function. And plain and simply, here are the rules. In order for a graph to be a polynomial function, first of all, there can't be any gaps, so it can't look like this, because there's a gap. So it has to be continuous. It can't even have a hole, similar to something like this. If it has a hole, you know, where that one value, for whatever reason, is not defined or whatever, that's not a polynomial function. So there can't be any gaps, no gaps, there can't be any holes, and finally it has to be smooth. And so this would be an example of not smooth, because right there, that's a very, very, very sharp point. Okay, so otherwise this would probably be okay, but there can't be any gaps, no holes, and has to be smooth everywhere. Okay, so here we go. Number 12. I look at that, I don't see any circles, so that means there's no holes. There's no obvious gaps anywhere, and it certainly looks smooth. The only question may be slightly, you know, in the positive x, maybe at 1, negative 2, but that's still smooth enough. It looks rounded to me that I can say that is smooth. So number 12, yes, that is a function of a polynomial, or that is the graph of a polynomial function. The next group, 13 through 15, just asks for the x and the y-intercepts. The rules to finding these have not changed. To find the x-intercept, we let y equal 0. Of course, there is no y equals 0, so it's just that particular value, f of x. So we're going to let 0 equal x plus 4, the quantity cubed, and this is to find the x-intercept. And so taking the cubed root of both sides, x plus 4 equals 0, and subtracting 4, x equals negative 4. So one of our intercepts is negative 4, 0. Now to find the y-intercept, we let x equal 0. Or in other words, we find what is f of 0. F of 0 would be 0 plus 4, the quantity cubed, which is 4 cubed, which equals, what, 64? And so, when x is 0, y is 64. And so there are this is the x-intercept, and this is the y-intercept. Continuing with that same type of problem, let's find the y-intercept first. So let x equal 0. In other words, f of 0. That would be negative 0 squared times 0 plus 8 times 0 squared minus 1. Well, it might help us out to understand 0 squared is 0, and 0 times anything is still going to be 0. So one of the intercepts is 0, 0. But in order to find the y-intercept, or the x-intercept, we need to let 0 equal the whole expression, and that is negative x squared, quantity x plus 8, and the quantity x squared minus 1. And it's very simple to set each one of these equal to 0. Negative x squared can equal 0. Divide both sides by negative 1. X squared equals 0. And square root both sides. X still equals 0. That's going to give 0, 0, which we've already written, so I'm not going to rewrite it. X plus 8 equals 0. Subtract 8 from both sides, so x equals negative 8. So negative 8, 0 is another one. And then finally, x squared minus 1 will equal 0. Add 1 to both sides, x squared equals 1, and take the square root of both sides so that x equals plus or minus the square root of 1, which is equal to 1. So that means it would be 1, 0, and negative 1, 0. And so the four intercepts will be 0, 0, negative 8, 0, 1, 0, and negative 1, 0. To complete this group of problems, we're looking at number 15. Same directions, just different problem. F of x equals x minus 2, the quantity squared, times x squared minus 9. Okay, first one, let's find y-intercepts. So let x equal 0, and we get 0 minus 2, the quantity squared, 0 squared minus 9. Okay, let's just work this out. It's a plug and chug. 0 minus 2 is negative 2, and we're going to square that. 0 squared is 0, 0 minus 9. Okay, negative 2 squared is 4, times 0 minus 9 is negative 9, and 4 times negative 9 is negative 36. So when x is equal to 0, y is equal to negative 36. Likewise, when we find the x-intercept, we let 0 equal x minus 2, the quantity squared, and x squared minus 9. And we're going to set each one of these equal to 0 and go from there. X minus 2, the quantity squared, must equal 0, and x squared minus 9 must equal 0. Let's take the easier one first. Add 9 to both sides. X squared equals 9. Take the square root of both sides, and x equals plus or minus 3. So that would mean 3, 0, or negative 3, 0. Now likewise here, take the square root of both sides, so that x minus 2 equals 0. Add 2, so that x equals 2. And so this is going to give us the answer of 2, 0. So the four intercepts here are 2, 0, 3, 0, negative 3, 0, and 0, negative 36. Question 16 says, find the power function that the graph of f resembles for large values of absolute value of x. Now what this means is, how does it behave in the end? Does it go to infinity? Does it go to negative infinity? Or does it go one way's infinity and one way's negative infinity? But regardless, polynomial functions will always either go to infinity or negative infinity. And so that's what we are trying to determine here. And so what we do here is we need to find the power function that it resembles. Well, the power function is always the item or the term of the highest degree. So here, all we really need to worry about is what degree is going on here. So in number 16, I've got x minus 11 raised to the 5th power and x minus 9 raised to the 2nd power. Well, once again, this part is going to be some monstrosity of a polynomial, but all I'm really interested in is the fact that this will be x to the 5th power. Likewise, this isn't a monstrosity, this only turns into a trinomial, but I do know it's going to be, as its highest power, a 2. So it's going to be x squared. And then I know, since I'm multiplying this, x to the 5th times x squared is x to the 7th. And so this inadvertently, I guess, gives us what it looks like, or what it behaves like, because the answer, what power function is it that resembles large values? It's x to the 7th power. Okay, number 17, it says use the x-intercepts to find the intervals on which the graph of f is above and below the x-axis. So I'm going to do that, and here it's going to really help if we think about the multiplicity, because if it just touches it, then we know if it was positive before, it's going to be positive after, and we're going to look at how to do this. But number 17, we have f of x is equal to x minus 2, the quantity squared, times x plus 5, the quantity squared. And the first thing we want to do is we want to find the x-intercepts, which means let y equal 0. So 0 equals x minus 2, the quantity squared, x plus 5, the quantity squared, and set each one of these equal to 0. So x minus 2, the quantity squared, is going to equal 0, and x plus 5, the quantity squared, is going to equal 0. Now if we take the square root of both sides, we get x minus 2 equals 0, technically plus or minus 0, but we're not going to really worry about that because there's nothing to worry about. And we get x equals 2. Likewise, we're going to take the square root of both sides here and get x plus 5 equals 0, or x equals negative 5. And realize we're only really interested in the x-axis, so that's all I'm really going to look at. And in particular, I'm only interested in the points negative 5 and 2. Because that's the only place where there is a 0. That means the graph is going along and doing something, and it's only going to hit the x-axis right here and right here. Now, the first thing we want to do is we want to determine, is it above or is it below the x-axis? Now, all we really have to do is pick some value in here somewhere and plug it into this and see, do we get positives or do we get negatives? So let's look. Let's plug in 0. 0 minus 2. Well, that's negative. But negative squared is positive. So we've got positive. And 0 here. 0 plus 5 is positive. Positive squared is positive. And we already said this was positive. So positive times positive is a positive. Now, we've determined that between negative 5 and 2, it's positive. It's above the x-axis. So then the question becomes, what does it do over here and what does it do over here? We can either pick negative 6 or some other value down here and some value up here, maybe 3. Or what we can do is we can look at the multiplicity. What's the multiplicity of this one? Well, since it's got a power of 2, it's multiplicity of 2, so that means it just touches. It doesn't cross the x-axis. So here at 2, it was positive, so it's floating around here. It's going to come down here, touch the x-axis, and bounce right back up. So it's going to be positive there as well. And then likewise, down here at negative 5. Well, what's the multiplicity of negative 5? Well, I look, there's a 2. Multiplicity of 2 means it simply touches and then it bounces right back. Well, it's up here, up in the top, doing whatever it wants to do. It comes down, hits negative 5, and then bounces right back up. So it's positive as well. The other way, like I said, would be plug in negative 6. Negative 6, negative. Negative squared is positive. Negative and a positive 5, negative 6 and 5 is negative 1. Negative squared is positive. Positive times positive is positive, so it's still positive. So you'll get it either way. It's just, I think if you look at the multiplicity and understand, does it touch or does it cross? Now, if it crossed at negative 5, then this all of a sudden would become negative. It would be below the x-axis. But to answer the question, where is it above and below the x-axis? It's above the x-axis, well, below nowhere. Nowhere does it ever get below the x-axis. But where is it above? Well, from negative infinity all the way up until negative 5. And at negative 5 it hits. And then it starts back up at negative 5, goes to 2. And then down at 2 it hits it and goes right back up. So it's above almost everywhere, except at negative 5 and at 2, because it's right on the x-axis there.